The difference between a new gasoline car's average cost of $40,000 and an electric vehicle's average cost of $50,000 is striking. Many prospective customers are now left wondering, is it really possible to create an electric vehicle for less than $25,000? Can AI make it into a reality? Let's see. Beneath the surface, the market for electric vehicles is being shaped by more than simply tax subsidies and Tesla's tactics. Automobile manufacturers are drastically rethinking EV technology and production procedures, opening the door for a number of new models that will lower the cost of ownership and increase the adoption of EVs. The desire for an electric car for around $25,000 has turned into the automotive industry's holy grail. The possibility of an affordable EV in the US and the EU is still attractively out of reach, despite a rush of promises from industry titans like Ford, Stellantis, and Tesla. Trade taxes and high margins mean that even if some Chinese OEMs have been able to bring their prices down, Western consumers still face higher pricing. Numerous theories exist regarding price reduction strategies. However, the secret has not yet been discovered. Could the combination of robotics and AI be the game changer that lowers prices? If we want to truly see affordable EVs on the road in the near future, then they must be. Thanks to significant federal and state subsidies, the existing EV market mainly serves premium and eager adopter consumers with an average vehicle price of $50,000. The mass market of price-conscious customers faces a substantial obstacle as a result of this pricing structure. It is noteworthy that these segments cannot afford even the typical new gasoline car, which costs approximately $40,000. It's important to cross the $25,000 mark for a number of reasons. First is the mass market appeal of lowering prices, this due to the reduction in global auto sales, which makes a lower price point more accessible to a wider variety of consumers, particularly those in the more budget-conscious groups. Furthermore, converting to electric cars can save a significant amount of money, annually around $1,000 on average over gasoline, making EVs a more affordable choice for the majority of people. Next will be the market share, where the number of passenger automobiles worldwide is now estimated to be 1.2 billion. Of which the EV fleet makes up a small portion. Even though the 10% fleet benchmark has been reached by several nations, a $25,000 EV has the potential to double or even triple in the market share that EVs currently hold in the US and Europe. This might result in millions more EV purchases per year, which would have a big effect on the new car market as a whole. Then lastly, coming on to green transition, which is the shift to more environmentally friendly modes of transportation, would be accelerated by an EV in the price range. Driving a car contributes more than half our transportation-related emissions. When combined with e-bikes, public transportation, and the infrastructure that supports them, EVs would greatly improve local air quality, lower greenhouse gas emissions in the region, and strengthen national energy security. Guys, do EV manufacturers overcome the hurdles to achieve a $25,000 price point? It's obvious that reaching a $25,000 price threshold is difficult. It calls for significant adjustments to the main components and manufacturing processes of EVs. Developments in battery and motor technology, more especially their optimization, efficiency, and energy density, are essential to reducing production costs because these components are the most expensive parts of an electric vehicle. Furthermore, manufacturing time, material prices, and complexity can be greatly decreased by concentrating on effective chassis assembly procedures and getting rid of pointless complexity and processes. Through combined resources, transparency, and simplified procedures, cost reduction is made possible via higher volume manufacturing and tighter supply networks. Moreover, car bloat needs to be reversed in the never-ending push toward larger cars. Form factors that are more compact, light, and effective are required. Although some people may find it difficult to accept, downsizing is necessary to achieve affordability and has been the trend for many things, but cars have so far escaped it. Can AI, robotics, and blockchain help? The automobile industry is set for an enormous shift. Some innovators have begun to investigate the important areas of potential that these merging technologies open up. For example, generative AI can be used to accelerate simulation, prototype, and development cycles, and optimize the design, materials, and assembly of batteries, motors, and vehicles. Robots with AI capabilities can automate repetitive operations on product lines, improve workflows, accelerate output, cut down on downtime, conduct automated inspections, and lower the risk of human error. Blockchain with AI capabilities can also optimize inventories and logistics, enabling safe data exchange, tracking supplies and components, and on-time delivery while cutting waste. Altogether, these developments target the crucial routes to reducing manufacturing costs, improving productivity, and eventually realizing the electric vehicle. So, want to know who can deliver a $25,000 EV? In fact, Tesla is leading the EV field in the competition to produce the eagerly anticipated $25,000 vehicle, although traditional OEMs like Stellantis and Chinese manufacturers are making significant headway. Geopolitical trade concerns have resulted from Chinese OEMs using their cost advantage derived from lower labor costs and strong government support. For example, BYD has successfully entered various low-cost EV sectors in China and nearby regions, but it has not yet made inroads into the US or Europe. Conversely, US and European OEMs have well-known brands and distribution systems, but in order to cut costs, they must modernize their manufacturing techniques. Interestingly, Ford has also recently revealed plans for a cost-effective electric vehicle architecture that might be the basis for several different models. Although they have a good reputation for efficiency and quality, Japanese and Korean OEMs need to concentrate on bringing down their costs in order to remain competitive. Electric cars are only as good as the networks they run on, much like smartphones. A strong infrastructure for charging EVs is essential for their broad adoption. The US has been slow to provide dependable charging infrastructure, with Tesla being the exception, in contrast to Europe and China, where charging networks are well established. Large-scale investment is necessary, and utilities are essential in making sure the system can handle the increased demand for electricity while growing renewable energy storage and sustainable charging sources. Even if EVs are an acceptable substitute for gas-powered automobiles, a complete multimodal strategy is required to create a transportation system that is really sustainable. Improving the infrastructure of public transportation is crucial to reducing reliance on private vehicles, especially in cities. At the same time, investments in secure and easily accessible cycling infrastructure encourage people to choose bicycles for shorter urban commutes. A connected network of electric transport choices is created by combining public transportation, e-bikes, and EVs. This leads to a significant decrease in pollution emissions and promotes sustainability in transportation. So, how does Tesla plan to lower costs? At its Investor Day, Tesla unveiled a daring plan to use manufacturing and car design breakthroughs to cut unit production costs by 50%. Additional cost savings are anticipated as a result of the company's vertical integration, which involves internal equipment manufacture and battery design. According to Tesla, drive units may be purchased for as little as $1,000, which is an industry first. However, while Tesla seeks to make affordable electric cars with a $25,000 entry-level EV, traditional automakers are still wary of entering the low-end market and instead favor larger, more profitable vehicles. Ford and Hyundai have no immediate plans to produce lower-end EVs, while GM is considering ways to increase profitability by adding premium features to smaller EVs. Still, doubts about hitting the targeted price points and profitability remain. With significance for the future of the automobile industry as a whole, the development of Tesla's pricing decisions and their effective market competitiveness continue to be important points of interest. In brief, the objective of creating an electric vehicle for less than $25,000 is a complex one that is influenced by market forces, competitive pressures, and technological advancement. Although firms such as Tesla have exhibited significant progress in cutting costs by use of vertical integration and inventive production methods, doubts continue to exist regarding the practicality of fulfilling this assurance throughout the automotive sector. Typical automakers must strike a balance between affordability and profitability. As a result, some choose to focus only on higher margin markets. Success in reaching the sub-$25,000 pricing point depends on a number of variables, such as improvements in battery technology, supply chain efficiency, and customer demand. Furthermore, government policies and regulatory incentives may be very important in encouraging the use of electric vehicles and supporting cost-cutting measures. In the end, advancing innovation, affordability, and sustainability in the automotive sector will require a coordinated effort from all industry players in order to make electric cars more widely available. What new methods do you believe are required to make electric vehicles that cost less than $25,000 a reality? Please share by expressing your opinions. To keep up with the most recent advancements in electric car technology and the shift to environmentally friendly transportation, like, share, and subscribe. Adios.